In the next 5 minutes, we're going to build a retrieval augmented generation chatbot, RG, end-to-end in Python, using Azure OpenAI for embeddings and chat completion, and Azure AI Search as the vector store. By the end, you'll understand the full architecture, the ingestion pipeline that loads your documents, the query flow that grounds answers in your data, and exactly what to verify when it's running. The goal is that you could rebuild this from memory. No magic, just real service names and real decisions. Let's go. Here's how the pieces wire together. A user sends a question to your Python backend, say an Azure function or a container app. The backend first calls Azure OpenAI to turn the question into an embedding vector. It sends that vector to Azure AI Search, which returns the most relevant document chunks. The backend then stuffs those chunks into a prompt and calls Azure OpenAI chat completion to generate a grounded answer. Separately, an ingestion job loads your source documents into AI Search ahead of time. Keep your keys in Key Vault, never in code. 2 Azure OpenAI deployments are involved, one embedding model like text embedding 3 large, and one chat model like GPT-4o. Retrieval quality lives or dies on ingestion. The pipeline has 4 steps. First, extract text from your sources, PDFs, Markdown, whatever. Second, chunk it. A good rule of thumb is 500 to 1000 tokens per chunk with about 10 to 15% overlap so you don't cut sentences in half. Third, call the embedding model to get a vector for each chunk. Batch these calls to stay under rate limits. Fourth, push each chunk, its vector, and metadata like source and title into your AI search index. Run this as a batch job and rerun it whenever your documents change. Your AI search index needs a vector field configured for the right algorithm and dimension count. Here's the key part in Python using the search index client. You define a searchable content field and a vector field whose dimensions must match your embedding model exactly. 3072 for text embedding 3 large. Attach an HNSW vector search profile for approximate nearest neighbor lookup. My recommendation: enable hybrid search so you get both keyword and vector matching, plus semantic ranking on top. That combination consistently beats pure vector search on recall. Now the runtime path, executed on every user question. Embed the incoming question with the same embedding model you used at ingestion. This is critical. The vectors must live in the same space. Send that vector to AI search and ask for the top 3 to 5 chunks. Build a prompt, a system message that instructs the model to answer only from the provided context and to say it doesn't know otherwise. Then the retrieved chunks, then the user question. Call chat completion. Finally, return the answer along with citations back to the chunk sources so users can verify. That grounding instruction is what stops the model from inventing facts. One decision worth calling out. Do you orchestrate retrieval yourself in code, or use the built-in integration where AI Search and Azure OpenAI connect for you? Doing it yourself, what I've just shown, gives you full control over chunking, prompt shape, and ranking, and it's easy to debug. The managed on your data feature is faster to stand up, but hides the retrieval logic and limits tuning. My rule of thumb: prototype with the managed path, but build the explicit pipeline for production where you need to control quality and cost. How do you know it's actually working and not just returning plausible nonsense? 3 checks. First, ask a question whose answer is in one specific document, and confirm the citation points to that exact source. Second, ask something not in your data at all. The bot should say it doesn't know, not hallucinate. Third, watch latency and token usage in Azure Monitor. Embedding plus search plus generation should land in a couple of seconds. And if costs spike, your chunks are probably too large or you're retrieving too many. Tune the number of retrieved chunks first. So that's the whole build. Ingest documents by chunking and embedding into Azure AI Search. Then at query time, embed the question, retrieve the top chunks, and have Azure OpenAI generate a grounded, cited answer. The single most important thing to get right is hybrid search plus a strict grounding prompt. That's where answer quality comes from. Your one concrete next step: stand up an AI search index with a vector field that matches your embedding model's dimensions, and index just 10 documents to test the loop. Model names, dimensions, and pricing change, so check the current Azure docs before you commit to a model. Build it, verify it, then scale it. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.